Okay, so here's the first scenario. 1, 5, -3, 2, 3, 9. One, 5, -3, 2, 3, 9. I just picked these numbers randomly. 2, 3, 9. Okay. So let's look at the first scenario. So all this set is the input for all of them. And this second set is the output for all of them. And I created a relationship. So I said 1 corresponds to 2, 5 to 9, -3 to 3. The question is this a function? So let's refresh our memory on the definition of a function. If for each input I get only one, not more than one, exactly one output, then this is a function. Each x value corresponds to only one y value. So the input is also called x for all of them, and the output is also called y. So the notation for any function will be f of x. Does it have to be f? No. It can be p of x. It can be t of x, and so on and so forth. It can be h of x. So this first scenario is a function. Each x value corresponds to one value in the output set of values. Also, this set has another name, and we used it when we graphed. What is the name of this set where all x values come from? Say it again. Very good. This is always the domain where the output is coming from. How do I call this set? Very good. Range. So the first scenario has domain 1, 5, -3, has range 2, 3, 9, and it is a function versus a relation. Good. Let's take a look at the second one. Is the second one, so the domain, whatever it is, the domain is still 1, 5, -3, and the range is still 2, 3, 9, but I would like to know whether this is a function or not. Let me rephrase one more time. Each x must correspond to only one y. Is this a function or not? It is. 1 corresponds to only one y value. 5 corresponds to only one y value. -3 corresponds to only one y value. So this is indeed a function, yes. How will I write the domain for both scenarios? Will be the domain. This time I have to write braces because I list. Normally this should be in ascending order. So I should have written them. It doesn't make any difference, but I should have written them as -3, 1, and 5. And the range the same. Still braces because I'm listing the elements. This is not an interval notation. It only has 3 numbers, 3 values. Okay, so let's look at the last scenario. Here I see 1 corresponds to 2, 5 corresponds to 3 and 9, and -3 corresponds to 3. Is this a function? No, this is called a relation. It is possible. It can happen, but it's not a function. The domain is still the same, -3, 1, and 5, and the range is 2, 3, 9. Okay. I would like us to look at a couple of graphs. For example, on page 231, here's a graph. Problem 82. I'm going to copy it for everyone to see. So in problem 82, and it goes down to so this is the graph. Now, we have several questions to answer here. My first question is this a function? How do I know whether it is a function or not? Exactly. By the vertical line test. So here's what I do. I draw vertical lines where I see the function. Here it makes no sense because the function is not there. Or the graph is not there. We haven't established. So if I draw vertical lines anywhere I want between this value, not at this value, but anywhere I want, I see that every vertical line, in other words, for any x, let's say x equals -3, I will find, this is the vertical line, x equals -3, I will find only one y value. Yes?
So if there was a hole somewhere in the function, would it not be, or if there was a hole in y, would it not be a function?
It's not defined over there.
Okay.
At that point. So for example, and that would be my next question, of course you're way ahead of me. I was going to ask you how much is x when x is -6, and you will have to say the function is not defined at -6. But here I started with -3, so for everyone to see how to read the y values. Right, so when x equals -3, y is -2, because I'm reading from this point. -3, -2. For any other vertical line, I will be able to read only one y value. So by the vertical line test, do we conclude that this represents a function or not? Yes, we conclude that it is a function. Yes, a function. I'll come back to the graph. I just want to emphasize one thing here. What if I have this situation? Let's say I have this graph, or I have this graph. Is this a function? No. By the vertical line test, when x is 1, I will be reading two different y values, and I will say a relation, not a function. What about this graph? The same thing. I will be reading two y values. So this is not a function, but is a relation. Coming back to our graph. So yes, it's a function by the vertical line test. Now I'm going to ask you, what is the domain of this function and what is the range of this function? The domain, bless you, the domain is from the leftmost point where the function exists till the rightmost point where the function exists. I would maybe using parentheses or brackets, I don't know, but it's from the leftmost point till the rightmost point on the x-axis. Indeed. So what I emphasized in green here, between this, but the point does not exist, so I cannot include -6 with the bracket. So it's open at -6 and it's including 0. In the same way, I will have to determine the range, but this time will be from the lowest y value till the largest y value where the function exists. Imagine that I'm crossing it now with horizontal lines to determine the range. What will be the range? -3 to 4. Which one is closed? Which one is open?
-3 would be closed, 4 would be open.
Yes, because that point does not really exist. So closed at -3 and open at +4. So my next question would be, and I already have the answer, If I ask you to find f of -6, means find the value of the function when x is -6, what will you say?
The value.
Very good. Undefined. And now if I ask you f from my graph, f of -4, what will you say? That was f of -3. Let's write also f of -3. That was -2. But now I want f of -4. Very good, 0. Which ordered pair did we read from? Comma. That's it. -4, comma 0. How do we call this point where the graph of a function crosses the x-axis? What is the name of that point?
Zero.
The 0, correct. It's also called the 0. I completely agree. The 0 of f of x. It has also another name.
X-intercept.
Awesome. The x-intercept of f of x. All these are the names for -4, comma 0. It's the x-intercept or the 0 of the function. Very good. What if I ask you now to find the y-intercept from the graph? What is the y-intercept?
Zero.
Do you all agree with 0, -3 as the y-intercept from the graph? 0 for x, -3 for y. Yes? One more question now. I would like you to find x such that f of x is -1. Back to my graph. I want to find x such that f of x is -1. What is given to me now? Is it x or is it y? Y is given. How much is it? How do I draw a line that represents y equals -1? I know how to draw a graph that is x equals -3. I already did that. This was the line x equals -3. But now I want to draw the line that represents y equals -1. Horizontal line at -1. Awesome. So I'm going to draw it. This line is y equals -1. It crosses the graph in one point. I will be reading the x value. Very difficult from my graph, but just say something. It's somewhere between -4 and -3. So x equals an estimate. It's very difficult to read from my graph. -3.8. So now I'm going to ask you, which ordered pair did you read from? I want to establish now something very important that even my calculus class has difficulties with. I have 10 more minutes left. Talk too much. Okay, so let's say I have this function. This is f of x. And let's say this is 10. Can anyone give us what this represents? And let's say this is point P. What will this? And you cannot give me a number. I just want you to tell me what it should be. No number. What should this be?
F of 10.
Of course. This must be f of 10. If the point is on the graph, for any x, the y coordinate cannot be created. It has to be f of 10. What about this point here? If this is 20, what will this be? Right, it has to be. So the coordinates of P are 10, comma f of 10. And the coordinates of Q, if I use this as Q, what will those be? comma, good. And now in general, I created now this point A, and I want its x coordinate to be x. What will this be? Say it again. If this is x, this would be, of course, we did the same thing with 10 and 20, right? It's the same thing. F of x. So the coordinates of A are x, f of x. This is the general idea. If a point is on the graph of a function and its x coordinate is blah, the y coordinate has to be f of blah. So please remember that. Okay. Now, I know I have just a few minutes left. I just would like to evaluate the function. Okay. So 8. So let's say we have a function that is, can you give me any function you want? Any type, anything, any function, please. It can be radical, it can be absolute value, it can be rational, it can be anything you can think of. Just give me a function. Very good. Now, here is what the function is telling me. This is another very important step. So we just came up with this. The function tells me this. F of whatever must be whatever squared plus 4. This is what I see, which tells me this. If you want me to find f of 0, I'll put 0 here, and I'll say f of 0 is 4. If then you say find f of 2, I will put 2 here, and I'll have 4 plus 4, and f of 2 is 8. And I can continue forever. What if you say, now this is a plus h? What will this be? A plus h. Stay with me because this is, as I said, this is very important. So now f of a plus h will be, can anyone dictate the first step? Not the simplified form just yet.
A plus h.
Very good. Plus 4. On the first day of classes, we made an agreement. So now when I look at a plus h squared, I know I'm not going to say what? I am not going to say, okay, right, I'm not going to say that. But what will I have to say according to our agreement?
A squared plus 2ah.
Very good. Very good. This is what I have to say because the binomial squared is a. Very good. That's why I started with that, because it will follow us everywhere we go moving forward. Very good. So this is what I want you to understand. When you are given a function, you have to analyze what it says to you. You have to look and say, okay, I see the pattern. It's asking me to square whatever you give me and then add 4 to it. Always keep that in mind. So for example, here's another function that is slightly more sophisticated, right? Let's say x plus 2 over 2x minus 3. What does the pattern say here? The pattern here says whatever plus 2, everything divided by 2 times whatever minus 3. So if you ask me to find f of 0, I'm asked to evaluate. F of x when x is 0. We don't really like to say that. We normally ask find f of 0. We don't say evaluate the function when x is 0. That's why we're using this notation, to directly go to f of 0. I know what to do. I have 0 plus 2 over 0 minus 3. And the answer is negative 2/3. I'm going to ask you now, of course, what ordered pair is this? Right, 0 for x, negative 2/3 for y. Perfect. Okay, what if for this particular function, let's say I am asked to find f of x plus h. Because I will be asked to determine this in the next section, and you will see what happens. I know the pattern, I understand the pattern, I see it, I know exactly what to do. Please dictate.
X plus h plus 2.
Perfect.
2 times x plus h.
That's it. Because I had the pattern in my head already. Whatever plus 2 over 2 times whatever minus 3. And this time whatever is x plus h. Yes, I will take it one more step and write 2x plus 2h minus 3. But this is it. There's nothing I can do. Don't attempt to simplify. They're all terms. You can only simplify factors. You cannot simplify the 2's, the h, x, nothing. Nothing, because they're all terms. And in a ratio, I cannot simplify terms. I can only simplify factors. Any questions? I just want to show one more function, and I would like you to identify the domain and range. We are going to look at these functions in chapter 3. So let's say x equals 2. This is a rational function. We don't know that yet. We have not gotten to graph those. We will extensively in chapter 3. But so now I'm going to ask you here just to identify the domain and range. What is the domain of this function?
-2,
Very good.
and then 2 to 8.
That's it. So this function exists for any x value except when x is 2. Perfect. Now I want to identify the range. And remember, it's the same idea, but just this time I'm looking at horizontal lines, not vertical lines, before I identify it, or in order to identify it.
-0, and then 0 to -1.
Very good. The only gap in the graph is here at 0. There is nothing else. The function exists everywhere. Oops, here it does not, and yet it continues to exist. So the only gap is at 0. Is this the graph of a function? No, because by the vertical line test, for x equals 1, I read 2 different values of y. Good. I still would like you to determine the domain and the range. Because we still can. So what is the domain? It's not a function, it's a relation, but it has domain and range. What is a domain?
Is it 1 and 2?
That's it. That's why we use braces, because we are identifying a finite number of elements. When we identify a finite number of elements, we have to use braces. Here, there is no way I can list these numbers. There is no way. So that's why I'm using intervals. But here, it's just 1, when x is 1 and when x is 2. And what is the range?
1 and -1.
Yes, -1 and 1. With braces again, because there are only 2 elements.